to my video for the movie recommendation system I'm trying to build. First, I use Jupyter and Python to try to implement the model. First, I load one of the datasets into Jupyter and Python, and I do some preliminary data exploration of it, and then I find out like total dataset is too big, and my laptop cannot like run it as a whole dataset. That's why I only use the first part of the dataset. And then I did some preliminary data exploration. As you can see, there are total like 4,500 movies, and there are total of 24 million ratings given by customers. And first, we can see that from the chart, more than half of the ratings tend to be positive, which means they are above 3. And I think that's because people tend to rate one movie when they think it is good, but when a movie they think is really bad, they just close the website and then leave it. And first, I try to do the data cleaning. I add one movie ID column to the data, and then I try to convert movie ID and customer ID into integers. And then for the data cleaning, I try to drop useless rows. First, I try to drop movies with 2 less reviews. Then I try to drop customers with 2 less reviews so that after trimming dataset would be customer and movies which with enough data. And for the after trimming size of the dataset, you can see it's only like 13 million ratings. So compared to the original dataset, which is 24 million, it's reduced its size largely. And then I try to pivot the dataset and then to load the movie title file into Jupyter. And first, I try to do the collaborative filtering for the recommendation system, and I use a threefold method to conduct the method. And specifically for this customer, I try to predict what movies he might like. And here is a list that he gave rating for, and by using the model, we can see these are the 10 movies that he might like. Also, I also implement the Pearson's R correlation method for the movie recommendation system, which after building the model, I can like predict which movie to recommend when a user type in one of the specific movies. For example, if the top 10 movie recommended for the Planet of Apes are these 10 movies, and for the movie Back to Future Part 3, these are the 10 movies that are recommended for it. Besides Python and Jupyter Notebook, I also use R to conduct this movie recommendation system. Because the movie recommendation model for R and Jupyter are using different dataset, I first try to load both the movie dataset and the rating dataset into R. And you can see there are a total of 100,000 observation, which is the rating, and there are a total of 9,700 movies in this dataset. First, I try to implement the content-based filtering, which you can see there are a total of 18 movie genres, which I try to split them into different cells. And then I try to create an empty matrix and then to iterate through the matrix so that you can see from here the rows are the movie IDs and the columns are the 18 different genres which record whether this particular movie are these genres. And then I try to create a user profile matrix, which for the first part, I try to convert the ratings of 4 or 5 into 1, else into negative 1, which leaves my matrix into a binary data set. So that you can see from this table, these are the user ID and these are the movies that has been given ratings for, and this is a rating which is now either positive or negative. And then for the second part of the user profile matrix, I try to substitute the null value with 0, and then I try to remove movie ID column, which leaves this complete table, which row would be movie ID and the column would be user ID. And also I did one particular data cleaning for this data set because like you can see from the number here that there are several movies that have never been given ratings before. So I try to remove these movies so that I can calculate the dot product of the movie genre matrix and the binary ratings matrix. And by calculating this dot product of these two matrix, I can look up the particular movies that might recommended for a particular user. So for the 18th user, these are the two movies and their genres for this user. And in addition to this content-based collaborative filtering, I also implement user-based collaborative filtering, which I create a rating matrix, which the rows are the user ID and the columns are the movie ID. And then I try to convert rating matrix into a recommender lab sparse matrix, which the recommender lab is the package I'm gonna use for this model building process. And then I create the model, and I use the UBCF, which is user-based collaborative filtering, and the nearest neighbor would be 30. And then I try to look up for the top 10 recommendations for the 10th user in the dataset. And this is the result for this particular user. And thank you for watching my video.